Conditional probability. Yeah, let's look at the basic formula when we deal with conditional probability. It's the probability of A given B, right? This is the notation we use. Some books do write it like this. Okay, so it means the same thing, right? Okay, so the probability of the event A occurring given that B has already occurred, okay, that is the probability of A given B, is the probability of A and B over the probability of B. That's how I'm going to call it, right? So probability of X given Y will be probability of X and Y over probability of Y. So let me write that here. Okay. If we change the notation, the probability of X given Y will be the probability of X and Y over the probability of Y. Okay. Let's look at an example that will help us along with this idea. A class of 100 students. Yeah, we've got 100 students. 60 are Hispanic, so I'm calling Hispanic H. And 10 of the Hispanic students are males, right? So I'm calling males M, right? Okay. So again, 60 are Hispanic and 10 of the Hispanic students are males. We asked to find the probability. Read the question carefully, right? Understand the question rather. Find the probability that a randomly chosen Hispanic student is male, right? Find the probability that a randomly chosen Hispanic student is a male. So straight away, we are dealing with Hispanic students. So given a Hispanic student, what is the probability that the person is male? So that's what we want to find, yeah? Okay, given that the student is Hispanic, find the probability that the student is male. So probability of M given H is what? Probability of M and H over the probability of H, right? So what is the probability of M and H, male and Hispanic? How many of them are there? 10, right? So it's 10 over 100. And how many Hispanic students are there? 60. So this will be 60 over 100. Remember, there are 100 students in total, right? So 10 over 100 over 60 over 100, you will get 10 over 60, which is 1 over 6. Okay. I'm using a formulaic approach, right? I'm just using the formula. But once you're pretty familiar with these ideas, you can go straight for the answer, M given H, right? Probability of male given Hispanic. How many Hispanic are there? 60. And of them, there are 10 males. Okay, so I have 10 over 60. You can do it much faster, but let me tell you again, the answer 10 over 60, you can cut short the method, but what I did was I have used the formulaic approach to working this answer out. Okay, so the answer is 1 over 6. Okay, let's move on. The probability, let me just move the screen up. Okay, great. Let me clear this. Okay, probability, okay, the formula again, right? So we want to be pretty familiar with this, right? Probability of B given A is what? Probability of A and B over probability of A. So remember that probability of A and B is the same as what? Probability of B and A. A and B happening together is the same as B and A happening together. So probability of B given A is just probability of A and B over probability of A. So we can write this thing here. Let me write the partner formula here, right? Okay, which is A and B over probability of B. So look at this, right? If we keep this numerator and we cross multiply, we will get probability of A and B as what? Probability of B multiplied by probability of A given B. Okay, probability of A and B, right? If you start by writing probability of B, then you must write, what must you write next? It must multiply by probability of A given that B has happened, right? Okay, so using this formula, you can see it straight away. Now what we are doing is this part here, we are replacing it with this part here, okay? Okay, and you can straight away see the idea of Bayes' theorem, right? So let me clear this first. And now look at this, yeah? We're starting here. And now probability of A given B, remember it is A and B over B, right? Good. So now what happens is, right? So A and B, I can write it as, let's say I want to write as A first, then this thing here, right, is A first. Now if A has already happened, then I need to multiply with what? B, given that A has happened, over probability of B. That's what you see here. Okay, this is basically Bayes' theorem, but I will talk about Bayes' theorem in a bit more detail in later. Okay, let's look at the next example, right? Let's look at the next. Suppose you roll a, we have a fair six-sided die, right? Okay, we are going to roll a fair six-sided die, and what's the story? Let me look at the question, right? Given that the result is odd, important, yeah? Given that the result is odd, so you roll a fair six-sided die, given that the result is odd, what is the probability that is 3 or less? Okay, that it is 3 or less. Okay, great. So I have used notation, right? Because we are learning the ideas. So I've used some notation. So let's get that correct. Yeah. Okay. What's the big deal? I have called the result as odd, right? The result as odd as A. Yeah? Let A denote the event that the result is odd. So if you write A, remember I told you about sets and all that, right? Subsets and all that. So A odd, so it'll be 1, 3, and 5. Yeah. So it's here. So the probability of A will be what? 3 over 6, yeah, or half. Now then what happens? I'm defining the event B. The event B is defined as the event that the number is 3 or less than or equal to 3. So it must be 1, 2, 3, right? B, the elements of the set B will be 1, 2, or 3. So the probability of B will be 1, 2, 3 over 6. Okay. Now I can write half, but I just maintain the 3 over 6 for us to get used to the idea of the number of elements in a set A divided by the number of elements in your sample space, right? The set S. Okay. Now, what do we want to find, right? Given that the result is odd, okay? So, given that the result is odd, what is the probability that it is 3 or less? Yeah. What is the probability that is 3 or less? So this is what we want to find. B given A. So not hard, right? B given A. I have got A and B over A. Probability of A, I don't have to worry. I have the answer here. Okay. What is probability of A and B? So A and B. Okay. We have got intersection, right? A and B. We have got A here. I have 1. Okay. 1. And then I have 3. And I have 3. That's it, right? So I have 1 and 3. So the probability of A and B is what? 2 over 6. We are done, right? So just plug it in. 2 over 6 over 3 over 6, you'll get 2 over 3. Okay. Now that we have understood conditional probability, let's just look at one more example, right? And the reason that I want to look at this example is because sometimes when we deal with conditional probability, it's useful to have a little table set up. Okay. You can follow along quite easily. Okay. Okay. Let's read the question, right? This is an old Society of Actuaries exam question. We have a public health researcher, right? Examines the medical records of a group of 635 men, right? Keep these numbers in mind, right? We are looking at the medical records of a group of 635 men who died in 1999. And then they discover that 160 of the men died from causes related to heart disease. Okay, so we are looking at 635 men who died in 1999, and 160 of the men who died, they died from causes related to heart disease. Okay. Moreover, 275 of 635 men who died had at least one parent, right? Had at least one parent who suffered from the heart disease. Had at least one parent means what? One or both, right? Okay. And of these 275 men, 95 died from causes related to heart disease. So there's lots of information there. So read it slowly and take in all the info first, right? What is the information given in the question? Yeah. Of the 275 men, 95 died from causes related to heart disease. Okay, great. Now, determine the probability that a man randomly selected from this group died of causes not related to heart disease and that neither of his parents suffered from heart disease. So you must read the question carefully and be careful of the notation that you're going to use. I will use some notation. You will see it in a minute. Okay. We're asked to find the probability that a man randomly selected from this group died of causes not related to heart disease. Okay. Not related to heart disease. And that neither of his parents suffered from heart disease. Okay. And then the second part, they say, determine the probability that a man randomly selected from this group died of causes not related to heart disease, given that neither of his parents suffered from heart disease. Okay. Quite a few lines there to get a grip on. Let's look at the solution. See what I've done, right? So keep an eye on the question and the numbers. Then you will see how I created this table, right? It helps. Okay, it helps. Keep in mind that you have 635 men who died in 1999, right? Okay, again, right? 635 men. This one here. Let me just get my pen right. Okay, there you go. This one here. Okay, 635. And then this one, I think you know what I'm talking about. This is about heart disease. This is no heart disease. Okay. And before we go on any further, right? Let's look at the heart disease part, right? Okay. 160 of the men died from causes related to heart disease. So this column here, the total must be 160. Okay, 160 died from heart disease. So if I have 160 here, this is what? Not heart disease, right? The complement. So this must be 475. How do I get that? I know this total is 635. So this one, and this is 160. So this better be 475. Okay, so it's not so bad, right? Okay, so now you know these numbers. Then 275, right, of the 635 men had at least one parent who suffered from heart disease. So I'm calling this first row, at least one parent had heart disease. I'm calling that event A, right? So that total number is 275. Okay, so you can fill this number out. So if I know this number, right, I surely know this number, right, which is A prime, the event that both parents, no problem with heart disease. So first row, at least one parent had heart disease. I'm calling it A and A prime, right? So I can fill out all these numbers. Then they tell me that of the 275 here, 95 died from, I'm looking at the question, yeah? 95 died from causes related to heart disease. So I can fill out this number. So once I fill out this number, right, I can get this number, and I can get this number, and I can get this number. Done. Okay, because I know all these marginal totals. That's what we call them, right? Marginal totals. This number, this number, this number, and this number. So once you fill out this table, it does help really, yeah? Okay, then you have to ask yourself, what do they want us to find in the question? Okay, what do they want us to find? Let's look at it. Okay, they want us to find the probability that a man randomly selected from this group died of causes not related to heart disease and that neither of his parents suffered from heart disease. So basically what they want us to find in notation form is this. Okay, so not heart disease and neither suffered from heart disease, HD prime and A prime. So where do I get these numbers from? Well, that's not hard. You already have this table, right? So we are looking at A prime and HD prime, right? So the number I need is 295. 295 over, so when you intersect, right, you get 295. 295 over how many do we have in total? Good, 635, and we are done. Okay. The second part is a conditional probability. Determine the probability that a man randomly selected from this group died of causes not related to heart disease, given that neither of his parents suffered from heart disease. So we're looking for this conditional probability. Given A prime, right? What is the probability of HD prime? So you write this formula here, like we know, right? Remember X and Y over Y, right? Same thing here. Just follow along. And this one we know already, right? This one we know already is just 295 over 635. And then I have probability of A prime. What is A prime? 360 over 635. And then you have this ratio here. You can write down your answer quite easily. Yeah. So I repeat, once you set this table up, you can write the final answer down straight away without doing it. I'm talking about conditional probability, right? You can write the answer down straight away without any problem. But I repeat, I am using a formulaic approach, so you are learning the ideas. Yeah? Because if you're doing this question and if you're already familiar with this, you can write this answer down straight away by looking at this divided by this. But that one, it'll come slowly to you. Okay. Now, let's move on, right? Let's move on. I want to talk about some idea of independence. Yeah, some idea of independence. Great. Let's clear this. Good. Okay. Now we're dealing with independent events. Yeah. If A and B are independent, okay, if A and B are independent, then you must know, okay, you must know that A and B is equal to A times B. Let me say that again. Yeah. If A and B are independent events, then the probability of A intersect B is the probability of A times the probability of B. I usually say it as if A and B are independent, A and B is A times B. Okay, this one here. Okay, so that's important. So if the probability of A and B is the probability of A times the probability of B, you can easily pick up the idea that probability of A given B is what? Probability of A. If they're independent events, right? If A and B are independent, it doesn't matter whether B has happened or not. So the probability of A given B is just probability of A. And the probability of B given A is just the probability of B, right? It doesn't matter whether A or B has happened, right? So it follows either by logic or by using the formula above. Okay, now let's look at one example. I won't go through the example in detail, but at least what you should do is you should pause the video and then try and do it yourself. See what they're saying, right? The blood pressure, high, low, or normal, and heartbeats, regular or irregular. Again, right? We have got blood pressure, high, three cases, right? High, low, or normal. And then you have heartbeats, regular or irregular. Of a random sample of patients, okay, things are measured. And of the patients, right, they give you some data, right? 36%, right, have high blood pressure. Let me clear this first, right? Okay. 36% have high blood pressure and 16% have low blood pressure. Okay, fine. 21% have an irregular heartbeat. Okay. Keep these numbers in mind, right? And then of those, be careful, of those with irregular, 1/3 have high blood pressure. That means what? Given that you have irregular, then the chances of having high blood pressure is what? 1/3. Of those with normal blood pressure, that means given that you have normal blood pressure, the probability of you having irregular heartbeat is 1/8. Okay, so understand the question first. Okay, where it is conditional, where it's not, and so on, and then you can start with the solution. So I have labeled H as I've used H for high, L for low, and N for normal, and then I have used I for irregular. Okay, I have used I for irregular. So that's the notation that I am using. You can work this out. Okay, you can work this out. So again, right, let me remind you, I'm using H for high. Okay, and then this is given in the question, 0.36. L is for low. This is also given in the question, 16%, 0.16. So straight away, you know this number, right? If I give you 36 and 16, you know 36 plus 16 is 52. 100 minus 52 is 48. So you know this, right? No, the probability of being normal is, or having normal blood pressure is 0.48. Now, irregular, they gave me, irregular heartbeat is 21%. So probability of irregular is 0.21. So if you have The irregular heartbeat is 0.21. That means regular heartbeat, right? That means not irregular. I prime, right? Is not irregular. That means regular. Will be 100 minus 21 is 79.79. Okay, so these probabilities you can write out yourself. I've already told you about it. They're conditional, and make sure you know what they want at the end of the question. What they want, right? They want what portion have regular heartbeat and low blood pressure. What's the operative word? This one, and low blood pressure, right? So please be a bit careful. Regular heartbeat means what? I prime, right? And low blood pressure is what? L. So this is what they want. Okay. Okay. I prime intersect L. So you can see I've set up a table. You can figure this out yourself, right? It's not hard. Just choose a group of 100 people because you're given percentages. I repeat, you're given percentages, so you can choose 100 people. Easier to plug in the numbers, right? That's what I've done. Okay. The other approaches, right? The other approaches, feel free to use it. I've given you a final answer. And once you see this 100 here, then you can see where I'm getting all these numbers from, right? 36, 16, 48, 21, 79, right? You can see all these numbers coming out straight away. Yeah. And then you have got, you can see all these, you can fill in all these numbers quite easily. Yeah. Okay. So go through it. Not difficult, right? Not difficult. I've given you a solution here, and I've only filled out all the important numbers. Yeah. Okay. To give you a hint, right? Okay, give you a hint here. I given normal, right? So we are looking at 48 people is 108. So 108 times 48, there you go. Not hard, right? Okay. So this one here is, you can fill out the rest. Yeah, it's easy for you because this is, you're looking at what? Irregular. How many people irregular? 21. High given irregular, 1/3. So 1/3 times 21 is what? 7. So I can fill out this number. I fill out this number, I can fill out this number, and I'm home. Okay, so you go through that. It's not complicated. I want to talk about an important idea next, which is Bayes theorem, right? So I'll start Bayes theorem with an example, and then I'll follow it up with some minor theory. But remember, when you talk about Bayes theorem, it's always about conditional probabilities. There are ideas called the law of total probability and so on. You can deal with Bayes theorem without even knowing about the law of total probability. But the law of total probability is something that you learn in a basic statistics class. Let's start slowly. Yeah, let's start slowly. Okay, let's start slowly. Great. So Bayes theorem is always a conditional probability, right? Probability of A given B, you know this. I told you about this. Okay, is A and B over B. And then I'm just replacing this, right? I'm just writing A first. If I write A first, then I must follow it up with what? B given A, right? Over B. So that's basically it, right? You mustn't, don't worry too much about Bayes theorem, right? There are a lot of ideas connected to Bayesian analysis, right? That you learn later on. But fundamentally, that's all there is. It is a conditional probability. A given B, A and B over B. But I want to write A and B differently. I want to write A first. So I want to write it as A. If I write A, okay, if I write this, then I must follow this up with what? B, right? But B, given that A has already happened. And basically we are done, right? So I just made a comment here, used when finding A given B when we are given B given A. That's basically the idea, right? So what I want to do, folks, is I want to use an example, talk about these things, and then I'll give you the theory, and then you'll be fine, right? So let's look at the example. These are kind of standard questions using Bayes theorem. Okay, we have variation on some society of actuaries problem, right? It's a good question to understand Bayes theorem. Now, an auto insurance company insures drivers of all ages. Now, okay, good. An actuary compiled the following statistics on the company's insured drivers. Okay. Now look at the table, right? Look at the table. Age of driver, 16 to 20, 21 to 30, and so on. Then probability of accident of that particular age group, right? The first group, 0.06, and so on, right? And then the portion of companies insured drivers who are 16 to 20, 8%. Okay. 21 to 30, how much? 15%, and so on. Okay. So keep an eye on this. This is the data that's given to you. Okay. Keep an eye on this. probability of these groups getting involved in an accident, and the portion of the company's insured drivers who fall in these age groups. Okay. Now, now that you know the data, right? What do? A randomly selected driver, read carefully, right? That the company ensures. Actually, this thing should be ensures, right? But never mind, right? Let's not be so critical about the question. Okay. A randomly selected driver that the company ensures has an accident. What's the story? This guy that the company selects has an accident. Okay. Given that the person has an accident. Okay. Given that the person has an accident, you're asked to find the probability that the driver is 31 to 65, falls in this age group. Okay. So you pick somebody, right, among your insured group, and then you find this guy is the guy who has had an accident. So now we are asking ourselves, what is the probability that this person that you picked was from the age group 31 to 65? That's it, right? So you see, we are dealing with conditional probabilities, right? That's why I said, let's talk about the example, and then you will find that Bayes' theorem is not so bad. Now, what do? A method that I like a lot, okay? I like to use what they call tree diagrams, right? So first, let me set out the all of these, right? This is an example of a tree diagram. Let me write it here, tree diagram. Okay, a tree diagram has got branches, right? A tree diagram has got branches. So from the first node, right? This is called a node. Let's not worry about all those things, right? Okay, this is called from the first node, you will have what? 4 of these branches. Now, those are pure probabilities because we are looking at what? The age groups, right? 16 to 20. What's the other one? 21 to 30. And then we had 31 to 65 and 66 to 49. So we have all these probabilities, right? Okay, these are all pure probabilities. Pure. You'll know pure in a second. Just give me a second, right? Now, those numbers are all from your table, right? Given to you, okay? 0.08, that last column, right? 0.08, 0.15, and then I have got, what do you call it? 0.49, and then I've got 0.28, okay? Now, then what happens? From this, after you've done this part, you go to the second set of nodes. Now, be careful. These are all conditional. I told you these are pure, right? They're not conditional. Some books like to call them marginal. I'll just call them pure, right? When I say pure, I'm saying they're not conditional. After this, okay, after this is called the first node, right? Henceforth, if you keep drawing in the tree diagram, they're all conditional. Okay, A conditional B. Then if you have another node after that somewhere here, then you have A conditional B, conditional C, and so on. Won't be so complicated, right? So these are all conditional probabilities, right? Let me clear this here. Okay, conditional probabilities, conditional probabilities, conditional probabilities, conditional probabilities. Where do I get these numbers from? From the second column. Okay, what is the probability that this guy has an accident given that he's from 16 to 20? So look at the table, 6%, 0.06. Okay, I'm calling A an accident, right? Then you look at the next number, 0.03. What's the probability that this guy has an accident given that he's from? So given that he's from 21 to 30. Has an accident given from this. So enough said, right? I think you get the idea. So these are conditionals. Now, careful, right? Watch carefully. I'm going to say something here. Remember the idea that we talked about, right? This is fundamental, right? So that you can pick up and run with this, yeah? I told you this. A given B is always A and B times B. Now, if you take this and put it up here, so you'll get what? Remember I told you A and B will be what? Let's say I write B first, and then I have to write A given B, right? So I'm just cross multiplying. So if you take a conditional and multiply it by a pure, you get an intersection. So if you go this way, okay, you'll get an intersection, right? So this will be A and 16 to 20, A and 21 to 30, A and 31 to 65, A and 66 to 99. Okay, so if you multiply your probabilities, this one and this one, you'll get intersections. Okay, you multiply a pure by a conditional, you will get a intersection. That is the idea. Okay, so now we can settle the problem, right? We want to find the probability that the driver is 31 to 65. So I've given you, this is what we want to find. Given this person had an accident, right? So what can we do? We can write A given 31 to 65 multiplied by, of course, you know this, right? I just told you. If you write, I just told you that here, right? So you can pick up very quickly. So 31 to 65 given A will be A given 31 to 65 times the probability of 31 to 65 over this one, probability of A. So this is where you find books will talk about the law of total probability. You will see that in the lines that follow in a few minutes. So just bear with me on that, right? Okay. So you already know the idea, yeah? How to handle Bayes theorem. Now, once you get here, the rest is what? Finding out the probabilities. Okay. You'll spend a little bit of time trying to find this. When I mean a little bit of time, I'm talking about using getting involved with some calculator work, right? This one here, right? Do you know this number? Of course. A given 31 to 65. How much is that? 0.02. You know that number. That's easy. What is the probability of 31 to 65? 0.49. You know that number. Those are the easy things, right? You only have to spend a little bit of time working this. And I told you how to get it. Okay. You want to find A, okay, the probability of A. So we're dealing with what? It can be what? Let me write it here, right? Let me write it here. The probability of A can be, can I just skip the, no, I think I should have tried. Let me write it here. Can be A and what? 16 to 20. Or it can be A and 21 to 30 and so on. Okay. I don't want to write the whole thing, right? It's just wasting time. So you know. So how do I get this? A and 16 to 20. Remember I told you to get intersection, you just go along the branches, multiply them out. So I have this times this. Can you see? Then I take this times this. Can you see? Then I'll take this times this. Then I'll take this times this. Okay. So I'll get the probability of A. This is the logic, yeah? This is the logic. And you work out, use the calculator, you'll get some number here. And you just plug it in and we're home. That's it. That's Bayes theorem, right? So I think Bayes theorem, when you deal with it, you'll find that I'm just telling you those things that are related to fundamental ideas in probability, right? Later on, we can learn a lot more about Bayes and so on. Now, I have given you a formal definition of Bayes theorem. You can actually look at it. Let me just clear this, right? Nothing to write home about, in a sense that this is the formal definition of Bayes theorem, right? Bayes theorem, more formally, I have to talk about A1, A2 up to AK, right? A partition of a sample space. You will find this idea in any textbook, statistics textbook that talks about Bayes theorem. You will find this about a partition of a sample space. Yeah. When we talk about partition, that means A1 up to AK, right? They are disjoint. They are disjoint. And when you sum the probabilities, right? A1, A2 up to AK is 1. Okay. Okay. So, and then you can write a formula, right? You can write all these things out and then you will get Bayes theorem. Basically, spend a little bit of time if you like. Go through these things. This is what we did earlier. Okay. This is what we did earlier. And this is what I called in my example. What was it? A, right? Probability of A. Okay. Where we had to sum a few things. Remember? That guy was accident and what? 21 to, I can't remember the numbers, 21 to 30, accident and 16 to 20 and so on. So we had to sum, right? That's basically it. So this is by way of a formal definition where we are dealing with the law of total probability and so on. If you're not sure what disjoint and all is, right, I can get out of it by just telling you now, if this is my sample space, I have A1, A2, A3, A4. Get the idea? Okay. I mean, here I had gone to AK, but we just talked about 4 of those. Well, we have got 4, they partition this sample space and they're disjoint, and the probability of A1 plus the probability of A2 plus the probability of A3 plus the probability of A4 equals to 1. Okay. So then you can follow the definitions of conditional probability and so on and get your Bayes theorem out. Now, let me just briefly talk about one more example and then we'll move to other things. Let's see, right? Maybe I can just talk to you about this question, and then you can settle this yourself, right? Okay. An insurance company, right, issues life insurance policies in 3 separate categories: standard, preferred, and ultra preferred, right? We are looking at risk selection, right? Okay. We have got standard, preferred, and ultra preferred. Of the company's shareholders, 50% are standard, 40% are preferred. So 50 plus 40, that leaves us 10%. Yep, correct. 10% are ultra preferred. The probability of dying in the next year is 0.01 for each standard policyholder, 0.005 for each preferred policyholder, and 0.001 for each ultra preferred policyholder. Great. Okay. Now, a policyholder dies in the next year. What is the probability that the disease was standard, right? What is the probability that the disease was standard? So I think you can easily settle this. I've helped you along here. Okay, just pause the video and see how to deal with it. The ideas are the same as what we had earlier, right? I tried to label this as well. Okay, I tried to label this as well. We have got the standard, preferred, and what ultra preferred, right? And then this is D is death, yeah, death. So I plugged in all the probabilities, right? 50%, 40%, and 10%, right? This one. And then this is the probability of dying given standard, dying given preferred, dying given ultra preferred. So they're asking you to find this. Okay. So you can work it. Okay. It's just probability of S and D, okay, over probability of D. Okay. How do you find probability of D? Not hard for you, right? This one times this one, plus this one times this one, plus this one times this one. I've done that here somewhere. Here you go. Okay. So that goes to the denominator, and then the top part you can easily get. Just follow along in my example and you'll be done. Okay. So not so bad. 0.7042, right?